Welcome back to MedBites. Let's break down the arachidonic acid pathway because this thing shows up everywhere. Biochemistry, farm, inflammation, asthma, all of it. All right, so the pathway starts in the cell membrane. You've got phospholipids and an enzyme called phospholipase A2, which converts the phospholipids into arachidonic acid. Now, why do you have to know this enzyme, phospholipase A2? Because steroids, so things like prednisone, which is a glucocorticoid, block phospholipase A2, which means they shut down the entire pathway upstream. That's why they're so powerful. Now, from arachidonic acid, you have two major directions. You have either the COX pathway or you either have the LOX pathway. So let's go over the COX pathway first. The COX pathway, you've got two other enzymes. You've got COX-1 and you've got COX-2. These are the targets of NSAIDs, so medications like aspirin, ibuprofen, naproxen, ketorolac, diclofenac, indomethacin. All of these medications I just mentioned block both COX-1 and COX-2. These are mostly reversible, except aspirin, which is irreversible. The only selective COX-2 inhibitor that you guys gotta know, it's celecoxib. And an easy way to remember this is to know that celecoxib has two C's in the word, so COX-2. Now, COX enzymes produce three key things. We've got prostacyclins, prostaglandins, and thromboxanes. Now, prostacyclins, there's PGI2, which gives you vasodilation and decreases platelet aggregation. Now, prostaglandins, which are also important, you've got PGE1 and PGE2. PGE1 increases uterine tone, which is why we give misoprostol for cervical ripening. And PGE2 causes vasodilation, fever, pain, and protects the gastric mucosa, which is why NSAIDs really show their effect here, and that's why we say you gotta eat before you take something like like an ibuprofen or an NSAID, because otherwise you can get a gastric ulcer because you no longer get that protection for the gastric mucosa. Thromboxane um, does the opposite of prostacyclins. It increases platelet aggregation and causes vasoconstriction. Now, the LOX pathway. The enzyme here is 5-lipoxygenase, and it produces leukotrienes. We've got LTB4, that's its own separate thing, and then we've got LTCD and E4. LTB4 is a powerful neutrophil chemotaxis signal. Do you know what interleukin also is a powerful chemotaxis signal? It's IL-8. Remember the word 8? Neutrophils ate the bacteria. And then you've got LTC4, D4, and E4 that cause bronchoconstriction, increased vascular permeability. These are huge in asthma. And these leukotrienes are where the asthma drugs actually work. So you've got things like montelukast and zafirlukast. So that's the lukast suffix. Let me write that down properly. So these guys, they are what we call cystenyl leukotriene receptor blockers. So they basically block the receptors where C4, D4, E4 work on. And then you've got xylutin, which goes earlier and works on the 5-lipoxygenase enzyme. So xyluton. There we go. So that's the whole pathway.